All right, hi there. We'll just do a couple of checks that everything is running as it should. Okay, so we've got some sound, and we're going to go through these three merit questions that I shared on the Instagram page. So hopefully you've had a chance to have a look over them first, and we'll get stuck into doing those worked solutions. Let's start with complex. I always prefer to start with the complex numbers. I like to do complex, differentiation, then integration. Okay, so we have this question here on complex numbers. Now, you can actually put this entirely into your calculator, but you will not get the merit marks for it if you do that. We'll do it at the end to check we've got the right answer, but we must solve this by hand algebraically for this to be worth a merit. Okay, so let's get stuck in with that one. First, by sorting out what I to the power of 7 is. And with this one, it can be tricky to keep track of your negatives. So actually, I would recommend that you write this out and then start grouping things together. So that would make a -1. This would make a -1. We have a -1 there, and then an I left over. So I to the 7 is going to become, well, -1 times -1 is plus, and then times -1 again, it's going to be a minus. So we have a negative I here. So on the top, we're going to end up with -4i minus I over 1 plus 2i, and then that will be squared. Okay, so I just need to, there we go. Now from there, I'm going to change that -4i into being a -5i, just collecting up the same terms there. And now we'll square that bracket. So -5i times -5i becomes 25i squared. And 1 plus 2i squared will be 1 plus, let's see, we'll have 4i and 4i squared. Remember, that's the same as if you're multiplying out two brackets, and it's tempting to lose the middle terms with that. So just be careful with those squareds that you do get all the terms that you need. So we have the -4i that pops out of that one. Okay, now I squared obviously is -1, so this becomes -25. And then on the bottom, we have the I squared here that's going to be a -1. So -1 multiplied by 4, it makes it a -4. We have 1 take away 4 is -3, and then add on the 4i. Now we're not quite finished because we want it in the form of being a plus bi, so now we need to rationalize the denominator. So we're going to do -25 over -3 plus 4i, multiply it by -3 minus 4i. So the conjugate of the denominator will help us to rationalize that denominator. Okay, so multiplying across the tops, we will have 75 plus 100i, and we get on the bottom 9 minus 16i squared. So I squared being -1, that's going to turn it into 9 plus 16, and 9 plus 16 is 25. And now dividing the numerator through by that 25, we will have 3 plus 4i. Nice and straightforward. Now hop on over to the calculator and you can know for sure if you got that question right. So let's pop that in as, I'm going to need a double bracket here, right? 4 times I to the 7, take away I, that will be divided by 1 plus 2i, and then we square it. We got 3 plus 4i. It's always helpful to know the little tricks on the calculator, even though this wouldn't have been enough to get you the merit itself. You needed to do the algebra, but it's really handy to be able to put it in and know when you're in that exam situation, check your answer is right so that you can go back and fix anything that needs fixing. Okay, let's go on to the next one, which is not integration, it's differentiation. Here we go. we've got this situation with a boy walking along. We've got the lamppost that's 5 meters tall. He's 1.5. So as he walks, his shadow is going to shrink. It's going to change as he's moving further away from that light. Would it shrink or would it get bigger? Not sure actually, but as he moves away, his shadow is going to change. Now I'm just going to, let's see if I can, I did prepare this earlier so that I can just remove the picture for a minute to give me a little bit more space, and we'll draw it back on, but in a way that's a bit more useful. So the bigger triangle that we had there, that had a height of 5, and we have the smaller triangle that's got a height of 1.5 for the height of the boy. Now those are two similar triangles. I'm going to call this bit here, the distance between where the lamppost is and where the boy is, I'm calling that x. And this bit here we'll call the length of his shadow L. Okay, now the information that we have in the question, we want to try and write that down. So as he walks away from the street light, he's walking at 2 meters per second. So the distance x, the rate it's changing over time, is 2. What we want to work out is the rate that the length of his shadow is changing. And I always approach these two questions in this way. Write down the thing that you've been told and the thing that you want to work out, and then use that to help you figure out how to get between the two things. So the thing we want to work out is the rate at which the length of his shadow is changing over time. Now, how can we use the thing that we've got to get there? So we've got dx by dt. We need to multiply it by dl to introduce the L that we need, and we need to factor or simplify away dx. So we need dx, so those dx's cancel, and we need dl to introduce the L, and then we'll end up with dl by dt. Okay, so we've got the dx by dt. Now we need something that links the L and the x together so we can work out dl by dx. And for that, we think about this as two similar triangles. So the bigger one that's x plus L and a length of 5, and the smaller one that's a 1.5 and L. Now, with similar triangles, the ratios between the sides will be the same, so that's going to help us link together x and L. If I did 5 over 1.5, that's the same as if I do x plus L over L. So the ratios between the sides maintain that same property, that same proportional relationship. With that, I can do some rearranging. So 5L is equal to 1.5x plus 1.5L. I'm going to times that by 2 just to make this nice rounded whole numbers, just to make it a little bit easier. Bring the L over to one side and we'll have 7L is equal to 3x. Now looking back at what I'm trying to get to, I want dl by dx. So I'm going to write this as L is equal to 3x over 7. So then if I differentiate that with respect to x, we'll have dl by dx is equal to 3/7. Now getting to that stage there, this was where the achieved was. So this bit just here, that's your achieved point within that question. Now let's finish it off. So now I can go on and find dl by dt, going back to the sort of chain rule bit that we had up here, that we can get dl by dt by doing dx by dt, which is 2, and times it by dl by dx, which is 3 over 7. So 2 times 3 over 7 is 6/7, or in this case it's sort of more normal to write it as a decimal, 0.857, and the rate that we're talking about is meters and seconds, so this will be meters per second. Okay. Just check everything's all right on the stream. Yep. Okay, so we're about 13 minutes in, give or take, because I didn't start straight away. And we've covered off 2 merit questions, so we just got a third one to go, and that's tracking pretty well. If we're hitting these merit questions where you can do them within about 4 minutes, then you can confidently go into that exam knowing that you can do enough of your merit questions across the paper to have a really solid go at merit, and then also try for excellence as well on top of that. That'll be plenty of time. All right, now integration. We've got a population situation. Now you should memorize the particular places that differential equations can be used, and that is population growth, radioactive decay, or some sort of decay is usually referred to as radioactive decay, but it doesn't have to be a radioactive situation, just something that's decreasing. So population growth, some sort of decreasing function, and Newton's law of cooling. Those are the 3 specifics, and I have a video that covers all 3. Memorize those ones. It will save you a little bit of time and thought in the exam. Okay, so the proportional equation that we've got here is that the population is changing at a rate that is proportional to the population of the town. So the rate at which that population is changing over time is equal to k, because that's how we always do proportionality. It equals a constant times the thing it's proportional to. So that'll be equal to k times p, because it's proportional to the population. Then we're given some information that in 2000, we're going to treat that as our start. That's where t will be 0. We started with a population of 12,000. 10 years later, we've got 16,000, and then we want to work out what it will be at 2025. Okay, taking that differential equation goes straight to the population will be AE to the KT. Now, if you have memorized this, you can go straight from this one to this one. I have skipped a couple of steps. If you're doing this manually because you haven't memorized it, you would separate the variables, bring p to the left, k and t to the right, integrate both sides, you'll end up with this equation. But if you can memorize that this turns into that, that will save you just a little bit of time. Okay, so now when t equals 0, we can use that to work out the values of the constants we don't have. So 12,000 is our population. That's going to be a times e to the k times 0. Well, k times 0 is 0, and e to the 0 is 1. So therefore, a is 12,000. When t is 10 years later, we have a population of 16,000. So that will be 12,000 e to the k times 10, so 10k. So I'll just pop over to the calculator now. We'll do 16,000 divided by 12,000 is equal to 4/3. So 4/3 is e to the 10k. So if we take log of both sides, then log of 4/3 will equal 10k. So k is 1/10 times the log of 4/3. You can do it as a decimal. I prefer to leave it like that because that's kind of cleaner. You're not, what's the word? You're not turning it into a rounded decimal instead. Okay, now the final question that we need to do is work it out in 2025. So in 2025, we're talking about it being 25 years later. So t is 25. The population will be equal to this equation here, but with the pieces in it that we've just worked out. So we've got a is 12,000, e to the k, which is the 1/10 natural log of 4/3, times by 25. Okay, so let's pop that in. I'm going to do it a little piece at a time rather than try put the whole lot in at once, because if we do that, you often make mistakes with how you enter it into the calculator. So let's start with, we'll do the natural log of 4/3. And I've got brackets just to make sure that it's not doing anything weird with that fraction. That will be divided by 10, then times by 25, then we raise e to the power of it, and then we times by 12,000, and we get our answer is the population is 24,633, or rounds up 634. Okay. The achieved point on that one, I'll just have to go find it 1 minute, was getting down to, just 1 second, I just want to check and make sure. 1, 2, 3. Okay, so seems pretty straightforward. I think the mark scheme is saying that the achieved was getting to this point here. That doesn't really feel like it is right to me. I think you'd probably need to work out at least one of the values of the constants to get the achieved. This is a reasonably old paper. It was from 2015. I feel like the more recent ones would have wanted you to have at least one of those values worked out of either A or K to be able to get the achieved mark. Okay, so that's us done. Thanks for jumping in, those of you that have been watching live. It's always nice to know that somebody's on the other end listening. And for those that are watching back the recording, hopefully you've paused on those questions and had a go at them before watching the worked solutions. I will post tomorrow's questions up on Instagram as soon as I've gathered them together, and we'll probably do a similar time tomorrow. I'll put that in the schedule and post it to the channel and let you know. All right, have a good day.